Hello and welcome to today's lecture. Today we'll basically discussing somehow about the Hugging Face models and how we can use them inside our PyTorch module. So pretty much what we have discussed so far is how we build this sequence of modeling. Like first we applied the embedding and then pass the output of the embedding to the LSTM and then after this to the linear model. So generating the final output into a single vector dimension. Okay, so basically all this pipeline can be also replaced by a single model, which is from the Hugging Face itself, that is pretty much pre-trained on this given task. For example, we are training for sentiment analysis, so we have a whole model built for sentiment analysis, and it is just going to pass the input into it and it will be generating the output that I need. Okay, only the main disadvantage here, like if the model doesn't have or produces low accuracy on your own private data set, it will need you to fine tune all the parameters of this model. And the problem is, while fine tuning these models, it is very huge number of parameters. So it needs a huge resource size to be uh, stay on and start the fine tuning on this. Another trick on this, as we have discussed earlier, is the transfer learning. If you remember from the embedding of the Glove lecture, that we also use another layer on over the parrot or over the Hugging Face model layer, and in that case, it can be fine-tuning only this linear layer based on what the Hugging Face model produces. So the Hugging Face will be freezed, as we have discussed earlier with the Glove. It will be freezed, so no gradient, and there will no any fine-tuning occurs to this model. Only the linear layer, the final linear layer or multiple linear layers can be fine-tuned, and the backbone of the model will be whatever Hugging Face model we choose. Before getting to the script, I need to show you somehow different types of models in the Hugging Face community. So, for example, here we have this OpenAI Whisper Large, which is a speech to text speech recognition module. And also, if you need also to check the latest models in the start here, also you can check that only NLP tasks or only computer vision tasks. And here is a multimodal, like text and image, both of them. But here, for example, we are most interested in the text classification, so we can copy paste any of these model names and start embedding them into our code. So let's get back to the code script and try to check how we can use them inside our model. Okay, so this is basically what we have built so far, and this will be basically totally removed and be replaced with a single layer, which is Barrett or GPT or any language model that we can use, and by which the forward propagation will be calling also this as we can, as you can see by now. Okay, so let's start with checking somehow how we can import this model. So from Hugging Face, sorry for that, it's from Transformers. It's called Transformers package. We can import Barrett, and it can also be Barrett model. and there exists also Barrett tokenizer. Okay, so it is not coding. As you can see, there exist multiple. It can be also distilled Barrett and wild Barrett. Uh, XLNet also. So there exist a huge number of models through this transformer or Hugging Face package that we can use. But for example, I just need to use a Barrett model and its tokenizer. Also, we can have this Barrett for sequential sequence classification or token classification. So, for example, if I imported this and I have this from pre-trained and I get the Barrett uncased base uncased, and this is the model. Okay, actually, Barrett have multiple versions of it. Like, for example, here we have the Barrett base uncased and the Barrett large uncased and the Barrett base cased. Cased or uncased. Uncased mean like it is only taking care of the lower case. It is doesn't care of the upper or lower. But here it is upper and lower being taken into consideration. Okay, so here we have retrieved the model with all its weights. Okay, if you don't have this Barrett model, it might show you some downloading progress bar. And here is the full model of Barrett. And this is the last layer, which is the classifier part. And it produces here this as 768 input, and the output would be 2. Also, our task here is to generate 2 layers. And for example, it also needs this tokenizer, so I can in order to try it, I need tokenizer. So Barrett tokenizer will be also for Barrett base uncased. That's the beauty of using this model. Like, okay, I should try from pre-trained, and then we just use them as follow. First, we apply some tokenization for the model, as we have discussed earlier, using this encode plus and give it the some reviews of it. Like if I check, for example, the text, and then we use let okay, for example, this I have an array of 5 reviews. Okay, and here I need to tokenize them, so I just pause them like this and determine the padding to be max length, and the max length to be, for example, 30, and the truncation to be applied as well. So let's see. Okay, so the error here, it should be a string, a list of tuple. Okay, so yeah, I think here it should be include batch include plus. Yeah, and also it should return tensors should be in pt. So now I have the output in tensor format, and this is a list of 5 okay, this is a list of 5 reviews tokenized. Okay, so after this I can have these reviews, the tokens. As you can see, it is a dictionary of uh, the input IDs, and here is the attention mask you can see here, and this is the token type IDs. Okay, so and now we can pass them to the model. Sometimes models accept some inputs like this. It's just taking the output. In that case, all the tokenization input can be passed through this. The values of the review tokens will be passed through the model, and here will be the output probabilities for each of these classes. And for example, if I apply, like, this is the predictions. Okay, and if I apply argmax on that, on the first dimension, okay, I think predictions should be 0. Okay, and if I apply argmax on that one dimension, so here it is all zeros. Also, you can check that some weights of the checkpoint are not used, was initialized randomly. So for example, we need to be fine-tuning this model on the downstream task. So for example, here I need to train this model, but some models are pretty much already trained, so you can use them just from one shot. Okay, so that's how we can use the parrot. For example, if I need to use the uh, GPT, so I can also from the transformers import GPT-2 tokenizer and GPT-2 model. Okay, and here from pre-trained, I can also check the GPT-2. Also here it have for example small or medium or large. Like I can check it from this list of names. I can here have GPT-2 only, which is the smallest one. It have only 12 layers and 117 million parameter. Okay, and also the GPT medium, GPT large, and GPT-2 XL. So all of these are derivatives of the GPT, and the terms of sizes will be increasing, and in that case, more parameters will be needed to be trained, and also assumed to be having a higher accuracy. Okay, so I've only used the GPT-2 as our model, and the tokenizer will be GPT-2 tokenizer. So it will be using the same, basically the same way here. I can also check the tokenizer and the reviews from the, okay, yeah. So this will be needed to be set inside, for example, it will be 1. Okay, as you can see here, the output is not as we didn't before because it's not GB2 for a sequential classification, but it's just GB2. And here, for example, I need to apply another layer over this GPT-2 model, and in that case it will be a linear layer that takes an input of this dimension and transform it into a two-dimensional way. Okay, so for example here I need to first, let's check the length of how many outputs, because there exists 2 outputs. Yeah, the next one is a sequence of multiple Ys. Okay, so this one is will be a 5 by 30, which is sequence length, and 768, which is the hidden dimension of most of the small Hugging Face models, and 5 is the batch size. Okay, So for example, here I need to have a linear layer. Maybe I need to concatenate these two these two values, and just have batch size by 30 by 768. And this linear layer will take, for example, the input of this linear layer will be 30 multiplied by 768, and the output, for example, will be 2. So in that case, I need to pass the predictions. I need to be reshaping it into batch size, which will be 5, and here will be -1. So the shape will be then combined onto 2 dimension only, which is the batch size, and this sequence size by the hidden dimension. And after this will be passed through this linear layer by passing them in that case. Like for example, FC will be passing by this and have these 2 dimensions. So I'm just giving you an overview of how we can use the Hugging Face models, any of them, inside this inside our model in the Torch code. And also you can check, for example, if you have some text classification, you can check, for example, this multilingual uncased sentiment. So you can click on it, and it also, you need to know, sometimes they have some usage code, so you can start with it. But as you have seen, I just need to copy this name and just insert it into our script here. For example, if I need to only use this already started model, I can copy paste this uh, into these types, and it might need to download if it is not downloaded. And after this, it will be only always giving the producing the outputs as much as you can see. For example, if it is still downloading them, okay, it's done. If I give this model the reviews output, if you can see here, it is based on the BERT model, and the output final layer, it is a classifier with 5 classes because it was trained on to 5 classes. I can also remove this layer and only use this layer. I will tell you how. For example, I need to only check the BERT model without the classifier, so I can check the base model. So the base model will be giving me only the BERT model with all its layers being trained, and this will be my model. And also, if I need to apply freezing on this model, so I can up looping across each parameters in this model. And if you can see, for example, here I can check that requires grad set to false. Okay, and again, if I check the model, you can see from this part, like, it doesn't have any gradient being required now, while the last layer only will be fine-tuned. Also, I can just use the base model and give it the input that I need. For example, these tokenized tokens, tokenized reviews, I can pass it to the model, to this base model, for example, and this output will be then, I take the predictions from this, and as we can see, we have this final layer. Again, I can choose it, use it to take the predictions from this only base model. So I'm showing you how we can use this model with a lot of flexibility, and how this Hugging Face community can be used in a very simple way. Also, in the dataset part, you will be sending to it the tokenizer, As you can see here, we have applied tokenization in this manner, but currently we need to apply it not in batch encode, but just encoding plus. For example, here, like I need to I need to send the tokenizer and also the max length size, and whether we need the padding index or not, or the truncation or not, I can pass it through here. And this is the data frame that I have. Okay, and also self dot sorry for that, tokenizer will be the tokenizer, and self dot max len will be max len. I just need to show you the main point about just to let you know how we can use this in the dataset part, because you might be using this. And this is the X. So first I need to get the reviews from here, from this df. It might be .ilog, for example, and I take this X from the text part. Okay, so for example, these are reviews. Okay, and this is our batch of reviews, and then I need to apply from the self.tokenizer. I need to apply encode plus. Okay, and I give it the reviews. I give it the padding to make it max length. Okay, and I give it the truncation to equal to true, and I give it the name of the max length itself to set it to self max length. Okay, so I'm just showing you how we can insert these okay, I can how can we use these embeddings into our model. So in that case, it will be returning this dictionary, which will be the input, as we have discussed before through this the previous lecture, and also the output, as you know. And this is torch.tensor. For example, this would be the reviews embeddings in torch way, in the torch dot type, and this will be the label or the score of of this index. Okay, so this, for example, more or less how we can use the tokenizer and the model of Buried within the from Hugging Face actually to the PyTorch code, as you can see. Also, I show you how we can more flexible we can use this model, and just you can change the names of these parts and try different models in order to increase the accuracy. Also, you can use different model for other tasks like question answering and sentiment analysis, and you can check all text summarization. All of these can be also done through the Hugging Face. Okay, so I hope you understand how we can use a Hugging Face model through our PyTorch script, and hope you got the intuition of how you can use it internally also within the dataset module. So see you then, and goodbye. Thank you.